and welcome to another episode of the Aleph Zero podcast. My name is Piotr Moczurad. You may also know me as Pete Urinsky, and I am the ecosystem tech lead at Aleph Zero. And I will have the pleasure of hosting today's episode. Today's meeting will be dedicated to exploring the Rust programming language and why we decided to choose it to develop Aleph Zero. I'll be joined by Aleph Zero's very own Michal Handzlik, whom we affectionately call Hans, to illuminate us on the subject.
Hi, everyone. It's a pleasure to be here.
It's great to have you here. So, without further ado, let's jump right in. And to my first question, which would be out of all the languages currently available, why has Aleph Zero decided to use Rust?
Well, first and foremost, because Rust is just a great language. It's fantastic to work with, and I'm a really big fan of it. But to give some broader perspective, Rust is a very new language. It's been around for less than a decade, and it's a system programming language, which means that it's this very low-level general programming language, kind of similar maybe to C++ in many aspects. And it has been designed and created I think the first version was released sometimes in 2015. So compared to other languages in this bracket, for example, the C++ mentioned earlier, it's a very, very new language, and it has been designed to tackle challenges that the computing industry is facing in the 21st century. So one of the main advantages of it is that it doesn't really need to bother about dragging behind it the tail of 4 decades of backwards compatibility. It can just focus on the problems and applications that that the computing industry is facing today and try to solve them in the best possible way. One of the most characteristic and revolutionary features of Rust is its almost paranoid approach to memory security, to security in general, mostly memory security and type security. And because of that, it has been almost immediately recognized as a great building tool for all kind of applications where the security is critical. Now, as we speak, there are already parts of Linux kernel or very deep internals of Microsoft Windows that has been rewritten to Rust because of its superior performance and superior safety. So it's probably not very surprising that it has been very eagerly picked up by the Web3 and crypto community, because we all know how important safety and efficiency in this kind of applications is.
Sure.
And as a consequence, it has been widely adopted in the Web3 community, and the main software stack that Aleph Zero uses to build the Aleph node, the main workhorse of our blockchain, is based on Substrate. It's this amazing software stack written by people behind the Polkadot community, Parity Technologies, namely, and it's written in Rust. So.
Right.
It's very easy to jump on that wagon, and this decision was partially motivated by us wanting to go with the fastest and the safest tool that is around there, but also by the fact that the Substrate library offered a lot of solutions that we could just take out of the box and use straight away, instead of having to re-implement it on our own if we decided to use some other language.
Right. And well, as far as I know, and this is before my time at Aleph Zero, so I'll actually be happy to pick your brain here. But as far as I know, the decision to use Rust didn't happen in an instant. It was something that we arrived at after some consideration, and actually uh, initially using Golang, actually another language in the similar ballpark as Rust. Am I right? Why even start with Golang and then change?
That's a good question, and let me walk you here through some Aleph Zero ancient history, because it all started um, around
When I
five
was very
years
very young.
when I was very young, and it all started with the consensus, with this idea that Adam Gongol and Michal Świętek had to create a new super fast, super secure consensus protocol. And after the initial phase of theoretical development, we decided that it's time to implement it and to put it into test in a real world. And we picked Golang for the reasons that are kind of similar to Rust. It's a relatively new language. It's quite simple, and it's a language that was built around the idea of concurrency. So this programming paradigm, that your program is not like a one line of instructions that are being executed in sequence, but it can be composed of multiple threads, multiple lines of instructions that then interact with each other. I mean, um, this kind of paradigm is something that is pretty much base of any kind of computer system or programming language nowadays. But Golang has this feature that it was kind of built with this idea as the priority. So it's a simple language, and it very easily allows to implement concurrent programming, and it's also quite fast. So around that time, we didn't really know Rust too well, and we had this good experiences from previous projects with Golang. So we decided to go with Golang. And the initial implementation, I think you can still find it on our GitHub repositories, was the Aleph consensus, now called Aleph BFT, written in Golang. So we implemented this consensus, and then we put it into some tests. And to be honest, I still remember how surprised I was when the first tests, when we analyzed the results of the first test, because this thing turned out to be just ridiculously fast. But it's probably important to mention here that blockchain is not only about the consensus. Blockchain is a system that's a distributed network of nodes without central leader. These nodes need to talk to each other, they need to sync their state. The consensus is what I'm trying to say here is that consensus is only one piece of the whole puzzle. So you need to have mechanism for accepting new transactions from the users, for sharing these transactions in a thing called mempool between different nodes, then for creating blocks, then for establishing consensus of what actually the next block contains and what is the right block out of the possibly large set of candidates, and then apply all the transactions in the block that result in some change in this thing we call state, which is like a distributed database held by the blockchain. So we had this brand new shiny Golang implementation of the consensus algorithm that was just super fast. And then we realized that there are, well, maybe not that we realized that at this moment, but then we were facing a situation in which we need to write all other pieces to make the Aleph node reality. And it's a lot of work. And around that time, we found out that there is this thing called Substrate, which I already mentioned. It's a big software library, a collection of tools that help to build blockchain. You can think of it in such a way that a blockchain node is this a machine made out of several components that need to interact with each other. And Substrate is just a big book with blueprints for all these components. And it was written in Rust, as I mentioned before. So we had this long and important meeting in which we were trying to establish further strategy. Should we go with our own in-house implementations in Golang of all other components and try to follow our own path, or maybe we should try to rewrite the consensus in Rust, and then this, of course, requires a significant effort to take the code in one language and properly write it in a different language. But then we are given this benefit of having many of the components that we need kind of standardized and waiting there for us to just pick them up and build our node around it. So we decided that it's more promising to actually switch to Rust. It gives us a much faster time to market, and we are kind of like standing on shoulders of giants. So all the components of Aleph Node that we took from Substrate are well battle tested, because the whole Polkadot ecosystem, meaning the Polkadot and Kusama and all the parachains, have been using these components for quite some time. So they are much more reliable and much more battle tested than like a greenfield implementation in Golang that we would otherwise need to do on our own.
Yeah, sure. I mean, I think, like looking back, I think it was a really wise decision. I think it's a common fallacy of taking on too much work and scope creeping and whatnot, and thinking we can do everything better. But in reality, you need to pick your battles, and I think this was a good battle to pick, basically. And now we
Yeah,
can.
but I think it's also important to stress here that even though Golang and Rust are both great languages, and I personally, as a developer, love to work in both of them, I think Rust is just better suited for this kind of applications that we're doing here. I mean, the safety and efficiency of it is pretty much completely unparalleled when it comes to the broad general landscape of programming languages. So yeah, even though initially we thought Golang is the ideal blockchain language, we kind of grew to accept the conclusion that Rust is the way to go. And it seems like that we are kind of right, because the uh, Rust is taking not only the Web3 industry, but in general computing industry, it's taking it kind of by storm. It's getting more and more popular every year, and my prediction is that when if this trend keeps it's going to become the de facto main system programming language within the next decade or so.
Right, yeah, and I think for good reasons. I mean, I personally come from a more of a functional programming background, and even there, everyone really respects Rust. So it's kind of amazing what they did with the language, by the way. But speaking of Substrate, and you mentioned this was kind of a pivotal decision and a huge stepping stone for Aleph Zero. But I wonder, what is it like to develop on top of Substrate day to day? How does it influence the developer experience, or even the architecture, the decisions that are made? So basically, what's the team's experience?
Um, so yeah, as I mentioned before, the Substrate is this. It's a general node, blockchain node template, which has like mm, you can think of it as like a Canva, and this Canva has slots for multiple different components. So you can pick your own syncing block syncing mechanism. You can pick your own consensus engine. So our experience was mostly trying to rewrite Aleph Aleph consensus, which in Rust we coined the name Aleph BFT for that, and it's also available on our GitHub page. You can go and you can use it, you can pick it and you can use it for other applications because it's kind of self-contained. But the first main challenge that we faced was trying to kind of put our consensus in a box that is compatible with Substrate. There were a few problems that we had to tackle on the way, but in general, I think that the project was very successful, and we ended up with a really nice integration of our own ideas into this well designed and battle tested software stack. So many components we just used the default ones because they were just so good. So the first version of Aleph Node was pretty much the uh, all the good things that are there in Substrate with consensus provided by our own implementation of Aleph BFT.
Amazing, but I wonder, because I look at the block times of Aleph Zero, at the times to finality, and it seems that most of the blockchains are not really designed to handle such speeds and throughputs. So I wonder if using this kind of out of the box framework, sophisticated as it might be, uh, was any like fine tuning necessary to actually make this keep up with Aleph BFT basically.
Oh yes, when it comes to that, we are really pushing Substrate to its limit. So the usual block times in the Polkadot ecosystem that uses Substrate are on the order of 6-12 seconds, and we decided that because our consensus is so fast. I mean, it can finalize blocks in less than a second. We decided that if the most crucial part of the blockchain protocol that we have is so fast, there's no reason to compromise it uh, by making other components to be the bottleneck. So our ambitious decision was to try to configure Substrate in such a way that it achieves 1 second block time. And it obviously came with its own set of challenges, and it kicked us in a back a couple of times. But in general, I think we succeeded, and the result was very satisfying.
That's amazing to hear. Well, because I think it's worth noting that the speed we're talking about here is not just a theoretical exercise in vanity. It's basically the first thing that the user notices, right, when trying to make a transfer or interact with the smart contract. So it's a lot of work, but I guess it's really worth it from the user's perspective. But
Oh yeah, that was incredibly satisfying when we first started our testnet or later mainnet, and then first users came and they started experimenting with the network and doing transactions. Like the one of the most common comments and then feedback that we got was, this thing is so fast that I could barely notice when my transactions happened. How do you guys do it? So yeah, like all our hard work that we put into squeezing the 1 second block time out of Substrate, it was well rewarded. We were so happy to see that it actually really works that well in practice in a real world environment.
that's amazing. But since we are doing this from developers to developers podcast, I would like to stay in the kind of developer experience area and talk about using Rust itself. So going actually down the level, because while everyone agrees, so like the Stack Overflow surveys and everything, that Rust is an incredible language, it also has the reputation for being quite hard to learn and quite hard to master. So I wonder, is the development team actually facing those challenges as well?
Yes, of course. I mean, I completely agree with the statement that Rust is difficult to learn. it features several. I know what would be the best word here. Mechanisms, several paradigms that are pretty much not present in any other programming language. So if is a someone may be familiar with other programming languages like Java, Python, C++, tries to pick up Rust, they are going to, even if this person is, like a developer with 20 years of experience, when picking up Rust, they are going to face new stuff. They are going to encounter notions that they never heard before, and they would need to, mm, maybe it's a bit of an overstatement, but they would need to learn a new way to think about the computer code, because of all the enforcements that Rust puts on programmers.
Yeah. So
And yeah,
I
it's fantastic to work with if it works, but if it doesn't, oh man, like the Rust compiler is the most unforgiving piece of tooling that I have ever worked with. It's obviously a consequence of the design of the language. It's so fast because it does a lot of optimizations. It's so secure because it enforces a lot of hard constraints and rules over the programmer. So mm, the slogan, which obviously is not 100% true, but I think it gives a good description, is that in Rust, if something compiles, it works.
yeah.
And that means that the errors you would in other languages maybe encounter later when you test, or when you deploy your uh, system to a test environment, in Rust you need to face them before you can compile. Compiling is the process of taking a computer code and translating it from this human readable programming language to machine readable zeros and ones. And yeah, before you compile, you cannot run your program because your program is not there in the form understandable by computer. So uh, in Rust, you have to put a lot of effort sometimes to even make your program happen.
Right. Yeah, and oftentimes I hear, about statically typed languages, especially with strong type systems like Rust. Oh, but I'm not productive as a developer because I have to fight with the compiler. Well, yes, you have to, but then you won't have to put out fires in production, which I think is actually a trade-off that makes sense.
Yeah,
Um,
I think it's a pretty good deal. I
yeah.
mean, one thing is that Rust compiler is so restrictive. It's very strict, and it will always often forbid you from doing things that you seem intuitive because your intuitions were developed while working with different programming languages. But to give it some credit, it has excellent error messages. So usually it just like tells you exactly what you did wrong, and often suggests how to fix it, and the
Yeah.
suggestion
Yeah.
is actually quite good. I mean, like sometimes working with the Rust compiler resembles a little bit interaction with Chat GPT. You're sometimes amazed how well this thing interacts with you and how vocal and helpful it is while giving you hints to achieve your goals. So yeah, there's a learning curve. You need to spend some time both learning the language and both and also learning to interact with the compiler. But once you get proficient with that, uh, the overall developer experience, I think, is pretty good. Another problem that faces well, it's not really a problem that you face as an individual trying to develop something with Rust, but if you have a project and you have a team of people who work on it, and the project is in Rust. I think one of the biggest challenges is to find people who are actually able to program Rust. As I mentioned before, the language is kind of booming in popularity, and there is much more demand for Rust developers than there are people who can do it well. So I think one of the biggest challenges over the course of the Aleph Zero project was to actually find people to join our team and to help us build and develop our software.
Right. Right. I mean, I remember joining Aleph Zero. I was definitely not a Rust expert, but I've been taught. It's been one of the great perks of joining. Actually, it's been really it's been a great learning experience. But moving on, since well, I I suppose most of the listeners are not actually planning to develop a blockchain nor a consensus for that matter, but well, I guess you can use Rust to do other things as well, right? So any use cases that might be interesting to our listeners?
Yes, of course. Rust has this amazing feature out of among other amazing features. It's very extendable and configurable language. Like there are some mechanisms in the language that allow you um, to pretty much build your own language on top of Rust, if it makes sense. Uh, and uh, and then you can have your dedicated language to do exactly what you want to do that relies on Rust and gets all the great features of Rust. So the efficiency, the safety, and the great collection of tools and libraries. And one of such applications is writing smart contracts. So there is this project called Ink, which is a smart contract programming language that is developed on top of Rust. It allows you to take regular Rust code, change a few lines, add a little bit of, as we say in programming, syntactic sugar, and suddenly your local program that was meant to be run on your local computer can be turned into smart contract, which can be uploaded to the deployed to the blockchain and yeah, do what the smart contracts do in the wild.
That's amazing, but I cannot help but wonder. With all the talk of Rust's complexity and the steep learning curve and an unforgiving compiler, uh, how does it look like from the perspective of a smart contract developer, right? Obviously, you want a lot of people writing smart contracts. So isn't using Rust here a barrier for entry?
A little bit, yes, because you need to learn new language, but the same thing could be said about Solidity, which is now the de facto standard of writing smart contracts. It's a language developed, created purely uh, for creating smart contracts on Ethereum and other EVM compatible blockchains. But one thing that we should mention here is that smart contracts are very specific types of programs. They are relatively simple compared, like if we compare even the quite a complicated smart contract with something like a blockchain node. The blockchain node is a huge, monstrous machine, and smart contracts usually are single files or maybe collection of two, three different files that sometimes can even fit on a single screen. So um, the actual subset of Rust that you would practically use in smart contract development is just a tiny portion of Rust, and this tiny portion the is the thing that Rust has common with all other programming languages. So things like uh, classes, methods of these classes, for loops, and whatnot. Basically basic data structures and basic control flow operations. So yeah, if you're a complete newcomer and you don't really want to learn Rust with all its bells and whistles, it's still a relatively approachable task to just learn the very basics, how you express basic programming concepts in Rust, and then with just this knowledge and this little bit of syntactic sugar that we call ink, you can be a pretty successful smart contract developer relatively easily. You don't need to spend too much time developing your toxic relationship with the Rust compiler. You can very quickly become productive and start to deploy your smart contracts to a live blockchain systems.
Speaking of becoming productive, I take a look around the Aleph Zero repositories and documentation every so often. So, can you tell us a bit about that? So, about the tutorials that may or may not be available, or at like additional tooling that Aleph Zero is building.
Yeah, sure. We were kind of maybe not forced, but this was the only reasonable choice. So as I mentioned before, we are facing this problem that we really need people because the project is growing, but we don't really there's really not enough Rust developers on the market. So we decided to go for a bit different strategy. We decided that we're going to look for people who are bright, who are smart, who are passionate about Web3 and blockchain industry, and we're going to teach them Rust because if they are smart and passionate, they're going to pick it up easily. So, as a consequence of that, we had to create quite a few onboarding tracks and a lot of materials that we use that can be used by people who just joined and would like to pick up Rust and Substrate relatively quickly so that they can start contributing to the project. So that was like our um, original experience with being Rust educators. We need to educate each other, but then it kind of followed further, and uh, mm, we are actively trying to actively go to the world, to the outside world, and share the message of how great Rust and Ink is. So in Aleph Zero, we have this. Mm, Well, probably you are the right person to describe it well because you are uh, the one who gives the most workshops. But we have a lot of materials that like tutorials that we share on our websites that help to somehow lower the entry barrier for becoming a smart contract developer in Rust. We also have the series of incredible workshops given by mostly you, but also
Thank you,
other
thank you.
people from our team.
Yeah, and I think maybe it's a good time to mention some tooling that we try to kind of give back to the ink and Rust community. Uh, I think mostly the ink community, right? So I've been I've been actually exploring this space a bit, and I stumbled upon a tool made by one of our developers that allows you to run ink outside of the whole chain context. So you don't need a node, you don't need a testnet. You can just experiment with it like with any other programming languages. I think it's pretty amazing if you want to get up to speed with development and actually get the speed while developing.
Yeah, totally. I think this is like the most serious challenge that we are facing now. Not only we as Aleph Zero, but there are also several other blockchains that decided to embrace this new smart contract ecosystem, namely Ink. And it's not easy. We are at the very beginning, and this thing is is pretty much brand new, and we are trying to be competitor to Solidity and EVM, which is an ecosystem that has been growing and being developed by thousands of developers all over the world, and we are here on square one, just starting. So obviously, we don't have as many great tools and libraries and educational materials, but I think that uh, the general Rust vibe of the whole ecosystem around the language is that of it has a very strong embracement of community. So there are a lot of people who contribute by writing new convenient Rust tools and libraries. There are a lot of people writing educational materials. In general, the Rust, the whole general Rust developer community is maybe it's a bit of an exaggeration, but it feels like a one big family. So people are very eager to help each other, and there's a lot of initiative to make the whole ecosystem better, and exactly the same kind of vibe can be seen in this just being born ink ecosystem. So we have several projects who already embrace it and deployed the ink smart contracts modules to their blockchains. And here in Aleph Zero, we are we feel very responsible for trying to make this first initial stage of the life of this ecosystem as approachable for newcomers as possible. So we've been developing and sharing several open source tools like the one you mentioned before.
Right.
Also, there's a tool called Ink Wrapper that we developed in house, and we shared it. We are in a close collaboration with other projects that develop on top of Ink, and also with people from Parity Technologies that are creators of Ink. And all together, we are trying really hard to address all the shortcomings that come from the fact that this ecosystem is brand new and maybe lacks a little bit of tools and educational materials. So we're putting a lot of effort into giving back to the community to try to together with other projects to put a solid foundation for this new ink ecosystem, because we firmly believe that it's a really viable alternative to the current state of the art being Solidity and EVM, and we actually believe it's quite a bit better. So we would really like to see it grow and become more popular.
Right. I think this also deserves a shout out to our community, both the developer community and the user community, who are just a great group of people, very very engaged, very helpful, very understanding. So yeah,
Oh yes, these
thank you
people are
everyone.
absolutely fantastic. All the projects that contacted us that are trying to develop their products on our platform, we are in close contact with them, and they contribute a lot. Just to mention one from the top of my head, there's this Azero Domains project that has
It's a
developed
zero
this.
ID now,
It's
actually.
a zero ID. I'm
Same
sorry.
great project, but new branding.
Uh, I got it confused. Sorry, but they developed this amazing in Katon uh, scaffolding. I would say is just a ready to use project consisting on both front end and smart contracts back end that you can just take out of the box and modify and have something. A prototype of your application working within a few hours. It's absolutely fantastic.
Yeah, yeah. I think it actually solves one of the biggest problems of people. not knowing how to start, how to get into ink development, well, there you have it. It's a great step towards like further adoption. Okay, I think we've covered all of my questions. Um, so I think we should be slowly wrapping up. Thank you so much for taking the time to give us the insights of the inner workings of Aleph Zero on some historical background behind the decisions. I was actually that was really interesting even for me to hear about that. Being an employee of Aleph Zero, but I didn't know all the backstories, so it was really interesting. I hope everyone else will enjoy it as much as I did. And thank you so much.
Thank you very much. It was a pleasure. I'm really looking forward for future episodes of the podcast. I'm happy to share my opinions and my point of view on this thing, and also a little bit of obscure history of the project. Um, Thank you, everyone, for tuning in, and yeah, have a good day.
Have a good day. See you on Twitter, on Discord, on Telegram, everywhere. Bye, everyone.
Bye.